Hello everyone. Today we are going to discuss the fifth problem of AtCoder beginner contest 339, which is smooth subsequence. So what is the problem? We are given a sequence A of n integers and we have to find the maximum length of subsequence A such that the absolute difference between any two adjacent terms is at most d. Okay. So let's take the first example. Here n is 4 and d is 2. Now we have to take the maximum length subsequence from this array 3 5 1 2. So we can take 3 1 and 2. Why? Because the absolute difference between 3 and 1 is less than equals to 2. Similarly, the absolute difference between 1 and 2 is less than equal to 2. Similarly, for the second case, you can check that we can take 10, we can take directly 100 110 and 120. So the answer will be 3. Okay. So how to solve this problem? Okay, so let's discuss about solution idea first. So the solution idea is that let's say we'll try to build something like DPI. Okay, DPI will be what? DPI will be the maximum length subsequence. The maximum length subsequence, or let me write it in text format. That will be better. DPI means maximum length subsequence till I. Okay, so DPI means maximum length subsequence till I. So how we can calculate this? Okay, how we can calculate this? Let's check that. So let's say we have some j, right? We have some j such that aj minus ai is the absolute difference is less than equals to d. Then we can take DPI equals to maximum of those dpj's plus 1. Okay, right? So there's the transition, right? We will try to find all the j's which is less than I, and this condition aj minus ai less than equals to d is satisfied. So DPI will be maximum of those dpj's plus 1, right? So how we can this is an order of n square approach. So this problem could be solved in order of n square using this approach easily with this simple dp order of n square. The time complexity will be order of n square. So now let's check the time complex constants of this problem. The constants on n is 5 into 10 to the power 5. So this order of n square solution is not acceptable. So what is the ideal time complexity? The ideal time complexity is something like order of n log n or order of n. Okay, so order of n log n or order of n. So for this type of problem you can think about having the value, okay, having the value uh, from some segment tree or some range data structure. Okay, so you are thinking about that from we'll try to store all the values from 0 to I in our we'll try to get the something like deep segment. We'll get dp of I minus 1 from segment tree, and we'll do dpi minus 1 plus 1. But there is a catch here, because this condition if we do range max on the indexes, range max on the indexes, right? We will try to find all the dp values from 0 to I minus 1. We will not check about this condition, right? We will not check about this condition, because all the values from 0 to I minus 1, there will be some values where this condition is not satisfied. So how will we differentiate between those, right? So instead of that, instead of finding maximum on the indexes, we can find maximum on values, right? Why? So let's take these constants. The constants on ai is 5 into 10 to the power 5, right? So the constants on ai is 5 into 10 to the power 5. That means that instead of finding dpi minus 1, we can try to find dp of val plus 1, dp of val plus 1, where what is the range of the val could be from ai minus d to ai plus d. So dpi will be nothing but maximum of this dp val plus 1, where val could be from ai minus d to ai plus d. So what will we do? We will try to find the maximum in the segment tree from ai minus d to ai plus d. But now you are saying that the first condition is satisfied, but how we are guaranteeing that the second condition is satisfied? The second condition is satisfied because we are traversing from the left to right of the array. So always the values in the segment tree will be of dpj's where j is less than I. Okay, I hope you get it, because all these values, all these segmentary values, segmentary of values is nothing but some dpj, right? Segmentary values is nothing but some dpj, and we are traversing from the left to the right, so all it is already guaranteed that j less than I, and we are taking the maximum from this range. Now the code becomes quite straightforward. Let's go through the code. So here is the template of segmentary, the segmentary of range max. I am not explaining how the segmentary is working. You can look at the code, or you can find any other sample template for maximum segmentaries. Okay. So here what I am doing is that I am taking the input here. Now we are trying to find, we are querying the segmentary from range ai minus d to ai plus d. Here what I am doing, I am the maximum, I am taking checking the condition that ai could be from 1 to 10 to the power 5. Here you can take 1 instead. Here I am taking that ai minus d should be 0. The minimum value of a minus d should be 0. You can take 1 instead. And similarly we are taking the ai plus d should be at maximum is what, 5 our constants. Yeah, right. So we are checking that what is the maximum value in the range from a minus d to a plus d, and we are doing +1 here, and we are updating the value max in the ai. So this ai is for the index. Here you can check that this the third parameter is index and the fifth parameter is value. The rest part is the start and end of the segmentary, and this is for the current node values. So these are fixed, but only changing things are ai and max, the index and the value, right? And at the end we are doing answer equals to maximum of answer comma mx. Instead of that uh, you can just discard this answer variable and just take the all the maximum in the segmentary at the end. That could be also possible, but I have done this. That would also would work. If you find this video helpful, please like the video and subscribe to my channel. I will provide the link of the code in the description box. If you have any doubt in any part of the video, you can always ask in the comment section. I will try to reply each and every comment. Thank you.